right, so today we're discussing potential energy, and we did a discovery lab over it yesterday. But in a nutshell, potential energy is the potential to do work. Okay. The actual definition of potential energy is the stored energy of an object because of two different things. Its position, which is what we kind of did yesterday with that lab. So we studied the effect of moving its height around to see what effect that had. Or it also could be the position of its parts. So the second part is a little bit more conceptual until you look at my examples. We have a bow for archery. When you pull back on the string, which isn't like a string, but when you pull back on it to shoot your arrow, you are changing parts of that object's position. You're changing the position of the string, and you're increasing the potential of that object to do work. So as you pull back on that string, it's changing its potential energy. And if you were to let it go, that's when, your arrow flies off. The other example is a spring. When you decompress a spring, when you make it shorter, you're increasing its potential energy. It's going to do something. It's going to off. Like my favorite were those little poppers that you could push down and they'd stick to the table for a minute and then just bing. Yeah. I love those. Don't put those on your forehead. But those are both examples of potential energy. Today we're going to talk about gravitational potential energy, which is just energy stored because of height. This is a lab that we did yesterday where you saw moving things around change that gravitational potential energy. In here, for various reasons that we don't really need to get into, gravitational potential energy is going to be UG. Ugh. So our formula is gravitational potential energy, UG, is equal to M times G times h. That's our formula. Mass times gravity times height. So m is mass, which we measure in kilograms. Gravity for easy math is on Earth is 10 meters per second squared. And your height is h, and it's measured in meters. Any questions so far? Energy is measured in joules. So when we find the gravitational potential energy of something, the unit would be in joules. All right, so we have my little snowman here, and he's on a snow trail that winds down a hill like this. Where is the snowman's highest potential energy? Where is his highest UG? We're so smart. And the lowest UG? Perfect. Got this. You don't even need me. So the first example problem says, if Sophia has a mass of 50 kg and the diving board is 6 meters tall, how much gravitational potential energy does she have? Huh?
I'm writing this kind of G.
I'm sorry. So you would take her mass of 50 times gravity here on Earth for easy math is 10 times the height of 6 meters. And what do you get? 3,000.
560.
Pretty straightforward, right? Then you're going to be given something else. Potential energy, for the most part, is a simple algebra formula. You get A equals B plus C. In any formula, you're going to be given either B and C or A and B or C and A. Like, it's just going to be a one-step equation. This entire energy unit is pretty much Algebra 1, which is good because Algebra 1, all of y'all passed. All of y'all did fine in. Algebra 2 has some struggles in it, but we're not messing with that stuff. Good. I'm glad for you. If a 3-kilogram chicken is sitting on a post 1.8 meters high, what's the UG, the gravitational potential energy of the chicken?
54.
Very good. 54 joules. Don't forget your units. Questions, concerns, or issues? Okay, cool. Underneath your warm-up today, You have 4 example problems. I want you to go ahead and do those for me, and then we'll go over them. All right, we're going to go ahead and go over them, starting at number 1. Football player throws a ball with a mass of 0.34 kilograms. What's the gravitational potential energy of the ball when it's 5 meters above the ground? So UG is equal to MGH, which would be 0.34 times 10 times 5. What'd y'all get? 32? 17. Okay. 17. There we go. 17 joules. A 2-kilogram book is on a shelf that's 1.6 meters high. What's the gravitational potential energy of the book relative to the ground? So you would do UG equals MGH, which is 2 times 10 times 1.6, which should be 32 joules. Don't forget that unit. It sounds to me like you're being pretty successful on this, which makes me very happy. "36-kilogram girl walks the top of the stairs that are 2 meter high. How much gravitational potential energy does she have?" Again, MGH 36 times 10 times 2, 720 joules. A can of soup has a mass of 0.35 kilograms. The can is moved from a shelf that's 1.2 meters off the ground to a shelf that's 0.4 meters off the ground. How does the gravitational potential energy of the can change? So at first, it goes mass gravity height 0.35 times 10 times 1.2. 4.2 joules. Then that changes 0.35 times 10 times 0.4. 1.4 joules. It did decrease. It decreased by how much?
2.8 joules.
4.2 minus 1.4 equals 2.8 joules. So they can decrease 2.8 joules worth of energy, gravitational potential energy. Anyone have any questions about that? Pretty straightforward stuff, right?